Hey everyone, my name is Anil, and in this video, we're going to explore how LLMs can and are being used to help instructors, teachers grade exams. Now, LLMs, as we know, have the ability to handle a lot of tasks and specialize in tasks associated with text and text handling, text summarizing, text interpreting, and so on. Right? They're really good at these tasks, and exam grading is an example of that. So, let's say you have an exam where you have this is an example of a physics question, right, at the high school level, and say the student has given you an answer sheet. So, this is the answer to this question, and this is an example that we look at as well, right? Now, first step, of course, is digitizing the answer and getting this to this, and that is what goes into the language model. Now that is a completely complex workflow in itself, and we'll not focus on that here. It'll be a different topic, right? But assume you know how to digitize this, right? You've got your image model, optical character recognition workflow, and you've kind of gone from text to this digital answer. Now what we have is a question and the student submission, right? And what we want the LLM to do is grade it. So either give us marks or at least compare, the solution with, what the instructor expects. So how do you do that? Well, the first step, as we mentioned, is a comparative analysis, right? LLMs are really good at comparing different pieces of text and telling you, what the differences are, and it works fairly well, as we'll see, for even problems involving math, right? Although LLMs do have a bit of a math issue sometimes, but for high school level problems and so on, it can do a pretty good job. So apart from the question and the submission, what you need to give the LLM is the solution, right? And then when you set up the prompt, you tell it what you want it to do is compare the submission with the correct answer, right? So the submission and the correct answer, which is the solution here, and you wanted to point out similarities and differences. This is kind of the basic idea of the prompt. And the code is available. So I'm sharing the code in Git. So you can go and check out the prompts that I've used, to get the answers. And so this is a quick kind of demo app we've put together for this. It's an HTML front end and a fast API backend with the workflows connected. So we're going to look at three modes. First one being the comparison, where you can enter the subject, the question, depending on the mode of grading, whether you have a solution or a rubric or so on, and the student submission. And when you hit grade, kind of calls the backend and gives you the kind of grading feedback from the LLM, right? And so we'll use this. I'll just show you where it is in Git as well, and you can go ahead and modify this later on if you want. And if you're looking to kind of play around with this, extend this, you can go ahead to the GitHub repository of Pixagan Laeyerz examples, and you click on the exam grader. So the grader app.py is the actual backend that kind of this HTML connects to with the three routes. And these are the workflows for each of these approaches that we're going to be looking at. And HTML grader models is the HTML page that we're looking at. So feel free to go ahead, play with this. You can kind of chain these, play around with these, add more, right? So let's look at how this example works, right? So it's a comparative solution check. So you enter the question, which is our question about Laeyerz law. You tell it subject, I'm setting compare with solution, right? And there are the other approaches that we'll look at. And then what I do is I give it the actual solution that I think is the correct answer, right? So as an instructor, you have access to that. So I said this is what I want as the correct answer, right? It displays the law, displays the equation, and gives an example to show conservation of energy. And then what do? I give the student's answer. So the student's answer is posted here, where what I've done is just taken that but removed some pieces of the puzzle, right? So it's actually here, it's missing the sign, just to tell you. It's got minus d5 by dt. I've removed the sign here, right? And that is kind of the difference. I've reworded this section a little as well. And then what you do, you hit grade submission. And you see, and I've sped this up a bit, but you see how the grader, the LLM, is able to clearly identify similarities and differences. It's able to say, well, the student has mentioned the Laeyerz law, described the scenario and the conservation of energy, but has goofed up the mathematical representation, has not shown the sign, and so the negative sign is important. So it's just going back on that and then saying the wording is slightly different. So you can see how, a grader like this very quickly is able to identify differences. What if we use a math problem? So again, a physics problem. I've just got these from a sample physics exam. And so it's a problem that involves actual mathematical steps, right? It's a resistance current problem where you need to solve and find resistance. We know the exact answer and we give a grade solution. And what I've done here is you look at this step here. You don't need to worry about the math, but you've got a step here, and I've just flipped it, right? I've gone 0.9 into r plus 2 is equal to 0.3 into r plus 7. I've just done it the other way, 0.3 into r plus 2 plus 0.9 into r plus 7. So what happens is this step is wrong, but then after that I've done the rest of the steps correctly. What it needs to do is point out that this step is wrong, right? And so after hitting grade, we see that again the LLM is able to point out similarities and differences. It picks out it's the same model, the rearrangement step, use of the two equations, and the approach and the result. But then it points out that the student swapped the steps. As a result, if you see, the rest of it is related to that. Inconsistency associated with that, inconsistency between the equated expression and the expanded algebra, and then the fact that the variable naming is different. I've used here I, E, and R, and here I've used I, E, and I, V, and R. So V for voltage, E for EMF, effectively the same thing, but and so it spots the differences pretty accurately, right? So we've seen how, the comparative analysis actually does a pretty detailed job, and it can give an instructor an understanding of how the student's answer differs from the specified answer, right? And it's important, using the LLM to grade, answers without a specified answer. It's just, creative writing or, a random essay on a topic can be harder. You need to tell it what to look for. Now, we looked at the math problem, right? Well, one of the issues with math problems that the analysis is flagging, but you can specifically ask it to flag, is a consistency check. So you want to see if the steps one after the other kind of match with the previous ones or are consistent. In which case, you don't need the solution if you've already done, say, the comparative analysis. You can just do the question and the submission. And now you tell the LLM, check if the steps are consistent. And this is a summary of that prompt. You can go and check out that prompt there. And as we'll see right now, the LLM actually again can give you a step-by-step analysis, especially for high school, early college level problems without too much complication in the math, that it can tell you how the points relate. And this applies to theory questions as well, where you kind of ask it to justify a point or so on. Now, of course, when you're doing a consistency check, you just give it the question and the submission, right? And I'm sticking to the math problem because this is where it's kind of interesting to see if it can pick out the discrepancy, and you're not giving it a solution. And so we see how the LLM picks out that it's not consistent, and it kind of points out, even without an actual solution being provided, that the currents have been swapped. And then because the steps have been swapped here in this place, it's the same as the previous example. He then does the rest differently, which means he has an issue there, right? And so it identifies that the numerical result kind of makes sense. It's able to do the math, which you shouldn't count on, but it does spot the inconsistency. And of course, what if we wanted to mark the answer sheet, right? So we've, it has given you, qualitative metrics, but what if you wanted to be specific and say mark? So you have the question and the answer, and what you need to do is give the LLM a grading rubric, right? Which is basically a marking scheme or a specification. And if you've graded an exam before, it's something you already have if you're grading an exam. So give that to the LLM, right? You tell it, actually, this is the student's answer, but look for a correct statement of Lenz's law in this case, a mention to the flux, and so on. You can also tell it, actually, if this is missing, deduct this much. So you can explain partial grading. This need not be one point. It can be a collection of points. If the student says this, this, and this, 1 mark. If misses this, deduct this much, and so on. The more clear or explicit you are about how it's supposed to grade and assign marks, the better it is. What you can also do is feed in the comparative analysis assessment into this as additional context. But I've not done that here. You have the question, the rubric, and the submission. And this is what you'll see in the demo as well. There are 3 different modes, right? So in the rubric-based mode, you just give it the rubric and you tell it, I've given you the rubric. You need to use, the rubric. Look at each point of the rubric, see if the student's solution satisfies that, and grade. Now, rubric-based grading is interesting because in my experience, it does really well in general, but in some conditions, if you're not specific enough with your rubric, right, especially for math problems, the LLM has a tendency to assume implicitly, if some of the steps are correct, that if you miss a step or two, it's still there. It assumes the student's understanding. So it's important to specifically in the rubric, like we've seen, tell it what to look for. And if something is missing, what to do, not to assume. Now what we can do is take the lens law example and use the rubric based grading. Right? And so what you do there is specify clearly what the points are that you're awarding the marks for. And then you give the student submission. So now you see how it handles the submission, and I've asked it to also return a confidence, telling it how confident it is about its own grading. So a bit of self-reflection for the LLM. And you see that the mark is awarded for stating the law, is deducted because the student got the sign wrong here, and is awarded for the explanation. And it describes that. So you see how a grading rubric seems to work quite well. Now, there are examples when you try the math problem, and I've left the prompt there. Go and try that out, and you will start seeing inconsistencies sometimes in some conditions, right? So depending on the solution the student has tried, you kind of see how it might be inconsistent and why you need to specify a rubric. So that's an experiment for you. Go ahead and try that out, and and I can in the test cases show you a few examples in the GitHub report, right? I'll add a few examples where it works and where it is an inconsistent approach. So the idea here is not to replace the grader. The idea is, say you have an answer sheet like this. You already have a question paper, and when you set the question paper, you give it the solution or the rubric and so on. And when the instructor sees different answer sheets, you can see an assistant. So with the answer on your screen, you get to see similarities and differences. With the comparative analysis, you get the consistency check if you want. You get the marking, and the instructor can go ahead and modify this. And this is how typical grader tools that are available today that use AI kind of work, right? And there are benefits and challenges, right? And as we are seeing, if the rubric is not well defined, you can see ambiguity. You can see in the comparative analysis a little repetition. Math problems can be a bit challenging, and which is why you don't leave the grading to the LLM. You use it as an assistant. But there are benefits as well, and the benefits are that you can handle answer sheets at scale, which is great for schools and colleges, large number of students, board exams, and so on. You can keep the grading transparent because the LLM tells you exactly why it's deducting or awarding marks. And it also gives you a lot of feedback on the student solution, which can be used to analyze the solution. It can be used across instructors to tell, the central authority, for example, what students are able to figure out and what not. Where, if multiple students have used a different approach, you can see that, you can analyze that and say, actually, there are, 50 students used one approach and 40 another. So how do you grade that? You get to see all this. There's a lot of transparency and data available that can then be used by instructors and the students kind of to analyze the exams, right? And those are the benefits of using a system like this. Now, for this project or this kind of video, there's a lot of scope for you to play around with. So like I mentioned, I've already put all the code in GitHub. You can check out the link in the description. It's in the Pixagan Laeyerz examples repository. So go ahead and play around with that, and some kind of suggestions that you can play around with: better grade rubrics, AI rubric generation, combining these pieces, making it a workflow or an agent, and of course, if you can build the first part of the problem, kind of handle the OCR part, again, very interesting. So hopefully this is kind of giving you a bit of an understanding and overview and a starting point for how AI-based or LLM-based grading kind of works and how it can be used. See you in the next one.